In this lecture, we'll solve few more problems on the concept of equilibrium of rigid bodies in a plane.
Now, let us solve this problem. Okay, so there is a rope and the tension is given. Okay, and rollers on a surface, the distances are given. Determine the tension in the cable and the reaction at each pair of wheels. Okay, so this is the free body diagram. At this wheel there is R1, this wheel's pair of wheels is R2, and then the weight is always vertically downward like this. That component is split into two because this is taken as X and this is taken as Y. It is based on our convenience. We can choose any way. If I take only this as X and this as Y, what will happen? I have to resolve all these three forces. Instead, I use only this force, resolving this force into this direction and this direction. So I can assume this as my X and this as my Y. Okay. So the Wx and Wy is calculated like this. And now, as usual, summation of Fx equal to 0, summation of Fy equal to 0, summation of moment about any point equal to 0. So moment about A equal to 0. Okay, moment about A equal to 0. So this will not produce a moment because it is passing through A. The tension will not produce a moment because it is also passing through A. This will produce a moment, and these two values are there. This will produce moment. Only unknown is R2. Straight away we can find out R2. About A, this will produce a clockwise moment, and this is a perpendicular distance. So negative, the value, and the distance. This about A will produce a clockwise moment. About A, you keep your finger here and try to move this, it will produce a clockwise moment. The perpendicular distance, how to find out the perpendicular distance? The line of action, draw a line which is passing through A parallel to the line of action of the force. This is the perpendicular distance, and this distance is given as 6, and it is producing clockwise moment, negative, the value of the force and the distance. And this will produce an anti-clockwise moment about A. Keep your finger here and move this force, and the tendency of the force will rotate anti-clockwise about A. So R2, it is positive, into the perpendicular distances, the line of action, and the line passing through A parallel to the line of action of the force is 50. That is the perpendicular distance equal to 0. R2 can be straight away found out. Now we can, as we discussed previously, it is not compulsory to have always summation of Fx equal to 0, summation of Fy equal to 0, summation of moment. You can have two moment equation and a force equation also. So if I take moment about B, only unknown is this R1. So in the similar fashion about A, similar fashion we can find out moment about B, R1 can be obtained. So this will not produce a moment, and tension will not produce a moment because the line of action is passing through B. So this will produce a moment, this will produce a moment, this will produce a moment, and that is given. This will produce a clockwise moment, this will produce an anti-clockwise moment, this will produce a clockwise moment about B. The perpendicular distance is 6, this perpendicular distance is 25, this perpendicular distance is 50. So you'll be able to find R1. Now summation of Fx equal to 0 because tension is the unknown force, and we have another only one force. So tension equal to 4980. Straight away we can find out the tension because only these two are the forces that are balancing, that are bringing the body to equilibrium, and the reactions are found out. I hope you would have understood this in a better way. We'll also solve this problem quickly. So you see there are 4 forces in this frame, and another cable is used which is fixed here at F. Okay, let us see what is that we have to find out. Reactions at fixed end E. So it is a fixed end, so all 3 reactions will be here. Let us now see the free body diagram. So this is the free body diagram. So all the 3 reactions are at the fixed support. Okay, other forces are known. Now we have a string. Okay, the reaction can be written like this. Okay, reaction can be written like this for the whole string. Okay, so now we can use summation of fx equal to 0. There is a x reaction, and if you resolve this into components, you have a x component that will be equal to this force. Since I have assumed in this direction Ex plus this equal to 0, this is the horizontal component. Okay, minus 90. So Ex happens to be left side, towards left. So my assumption is wrong. So that has to be in the left side. Solve Fy. We have Ey, all the 4 forces downward, and the vertical component is also downward. So this will be 4 into 20, all are downward, so that is negative. Straight away I'll be able to find out Ey. Similarly, if I take moment about E, so moment, already one moment is there as reaction, that we need to substitute. People sometimes forget to put this, then there will not be any unknown. So in this equation, ME is the moment about E as reactions. This is the reaction moment. I have assumed positive, so I have put plus. Then I have to find all the moments. These 2 forces will not produce a moment. 4 forces individually produce moment. Here I have put 4 into 20. Here I cannot put because the perpendicular distances are different. 20 into this is perpendicular distance. 20 into this is the perpendicular distance. 20 into this is the perpendicular distance. 20 into this is the perpendicular distance. So about E, all are producing anti-clockwise moment, and that is written here. And this horizontal force which is passing through E will not produce a moment. The vertical force will produce a moment. The perpendicular distance is 4.5. That is given here. The vertical component into perpendicular distance, and it is producing clockwise moment. So finally I am able to get Me as positive. So my assumption is right. This problem can also be solved in a different manner. As you know, the definition of free body diagram, we have to isolate all the bodies, okay, and then we have to solve. Now if I am isolating this pulley, okay, it's a frictionless pulley, it is treated as hinges, so there will be 2 reactions, and this tension will be acting here, this tension will be acting there. Both tension forces are equal, 150 Newton, but the inclination is different. So we will be able to treat that pulley as a particle and solve 2 reactions. We can find out that reaction, substitute here, then this reaction can be avoided. Instead, okay, those 2 reactions can be substituted here, and also this tension has to be put here. Okay, we can put this as well as 2 reactions, then we can leave this portion, okay, and we have to omit this. Then also we can solve this problem. So different ways are there to solve a particular problem. We'll be able to solve that. I hope you would have understood how to use the reaction for this particular support.
Let us solve this problem. See, there is a beam and it is supported at a hinge, and there is another support through a strut or a link. So there are two supports. So it's a hinge, it's a link. Now first, what we need to find out? We need to find out the reactions at the supports. So if we name this as A and this as B and this end as C, then there will be one reaction. I am assuming a direction. The sense I do not know, I am assuming it. So there is one force as a reaction. So that can be called as B. Okay, and at A, so we have two reactions, X and Y. So I can name it AY and AX. So let me draw the free body diagram, okay, more clearly. So this beam, this height can be neglected. I am just drawing that as a line, okay, it's a line, beam as a line, okay, and then this end A, right, use this AX, AY. I am assuming both the directions because I do not know the direction. I am assuming it, and the external forces are 300 Newton, 300 Newton. So this is 2 meters, another 2 meters, where you have B. It is inclined theta, and the direction as I am assuming in this direction, okay, and then you have 500 Newton and a couple 800 Newton meter. Fine. Right. So now, so this distance is 4 meter. Fine. So this is the free body diagram. We have to solve this problem. So we have to use three equations: summation of Fx equal to 0, summation of Fy equal to 0, summation of moment about any point equal to 0. Or we can use one force equation and two moment equations also. Here what I am going to do, first I will use moment about this point equal to 0. Okay, so summation of moment about A equal to 0. So when I am using that, these two will not produce any moment. So this force, and there is a moment that goes to 0. Okay, so this 300 downward, it will produce a clockwise moment about this point. So negative 300 into perpendicular distance 2 meter. This will also produce a clockwise moment. So negative 500 into 8 meter is the perpendicular distance, and I have a clockwise couple, okay, minus, so I am writing it here, minus 800, okay. And what about this force? It will have a vertical component and a horizontal component. So the vertical component is B sin theta. So B sin theta is 3 by 5, because this distance is 3 and this distance is 4. So the hypotenuse is 5. So the sin theta is 3 by 5. So the cos theta is B 4 by 5. Okay, so this component will not produce a moment, but the vertical component will produce a moment, and that will produce an anti-clockwise moment. So plus 3 by 5 B equal to 0. directly you can get B because only B is the unknown. Okay, that happens to be 2250 Newton. So straight away we are able to get this, and because B is positive, my assumption is right. Let us now find out these two. For that I am using summation of Fx equal to 0. I am adding all the horizontal forces. There are two horizontal forces, 1, 2. So Ax, I am assuming this direction is positive, and 4 by 5 B equal to 0. So B is 2250. So Ax is minus 4 by 5 into 2250. So Ax is minus 800 Newton. What does it mean? My assumption Ax is not correct or incorrect. So the original direction what we are obtaining is this. This is original Ax. Now what is Ay? Summation of Fy equal to 0. So this is considered to be positive. So Ay positive minus 300. Okay, this is positive. So 3 by 5 into B 2250, and the downward force 500 equal to 0. Only the vertical forces we are summing it and equating to 0. So now if we are solving it, Ay minus 550 Newton. So my Ay direction is also opposite. Whatever I have assumed is incorrect, so it is going to be downward originally. So we are able to use the three equations for a planar rigid body problem, and we are able to obtain the three reactions. Like our previous problem, here also you see there is a beam. The previous problem, there was a hinge support and there is a link support, and the body of concern was the beam. Okay, here also beam is drawn with red pen. Okay, so this is the beam and it is supported by rope using a pulley here. Okay, there are two bodies, but our focus is on only beam. Okay, so the reactions here, and what is this, by the way? This is the string or rope. So it will exert a tension. So if I draw this, this is the tension T, and you know it is a single string or a rope. So here also it will be T, the same T. The tension or the magnitude will be the same. Now there is an inclination. So the 3, 4. So the hypotenuse is 5. If this is theta, and then cos theta is adjacent by hypotenuse 3 by 5, and sin theta 4 by 5. There is an inclined force, there is a vertical force, and if you take the reactions, horizontal reaction, vertical reaction, Ax, Ay, okay, and also there is an external force. Let us now solve this problem. I am not drawing a separate free body diagram because it is pretty clear in this diagram itself. At C, it is resolved into two components. Vertical force, it is T sin theta, and horizontal force T cos theta. Now we will write the equilibrium equations. Okay, I take the moment equation first. So take moment about point A. Perhaps you can take moment about any point. Okay, so summation of moment about A equal to 0. So it is resolved into two components. So the T cos theta will not produce a moment. These two forces will not produce a moment about this point. Only this force T and the vertical component T sin theta and 100 force will produce moment. So this will produce an anti-clockwise moment. This will produce an anti-clockwise moment. So I'll take positive. So the perpendicular distance is 3t. This is 6. So plus 6 into T sin theta. T sin theta is 4 by 5. So 4 by 5. And it is clockwise moment. 100 into 10 equal to 0. So the T is, upon solving, you get, okay, T equal to 128.2 Newton. Okay, and now we can use other two expressions. Summation of Fx equal to 0. So Ax minus T cos theta equal to 0, since only these are the two horizontal forces, and Ax minus T cos theta is 3 by 5 and T is 128.2 equal to 0. So Ax is 76.92 Newton. So the third expression, so we are getting a positive value, that means whatever assumption I have made is right. Now we can use the third expression, summation of Fy equal to 0. So Ay plus T sin theta minus 100 equal to 0. So T is 128.2. So 128.2 sin theta is 4 by 5. So upon solving, you get Ay equal to minus 130.76 Newton. That means, okay, this assumption is wrong. This is the original. So we have found out two reactions here, Ax and Ay, and the other reaction which is acting because of this string, okay, is T. So three unknowns can be found out. So in this problem we found those three unknowns.